You want me to remind you to. Yes, sir.
Is it recording?
Yes, sir. It's recording.
It's recording. Yeah, no, visible. Now see, there are two types of oscillations. X-axis oscillation is taking place. Okay, now along x-axis, this is x-axis. Okay, along x-axis, a body is oscillating. This is the mean position. Okay, this cell phone is the mean position. Okay, can you see that? This is the mean position. Mean position is rest. Rest. Now this mouse is oscillating, means to and fro motion about mean position. This is the mean position. No, what I taught in the class number 1, if you see this, already the particle was at rest in the mean position. So this is what I taught, and then I told you at t/4 it will go this side, t/4 it will come back to the mean position. So total t/2 it will come back to 0. Again 3t/4 it will go this side. Again 2t/4, total 4t/4 it will come back to the mean position. This is what I told you. You remember this?
Yes.
Yeah. But if you see page number 196 in a textbook, no, a different type of representation is given. Listen carefully. This is one type of oscillation. When the particle actually starts from mean position, understood? At mean position, it is at rest. And it started only from mean position. This is what I taught you. Second type is what is given in the textbook. Why they have given that is, it makes some logically sensible idea of a simple pendulum. So they are giving an analogy of a simple pendulum in that page number 196. That's why they're starting only from mean, not from mean position. They're starting only from extreme position. Did you understand?
Okay.
My starting was at 0, 0. His starting was at what? A comma 0. Okay, this is A0. This is minus A0. He is starting from A comma 0 and leaving the pendulum. Then what happens? This is by 0, 0. This is his A comma 0 is the starting position. So after t/4, where it will be? At mean position. Next t/4, where it will be? At A minus A. Again t/4 it will be at mean position. This is 3t/4. Understood? For what I taught you, my 3t/4 was here. Remember? At the other extreme. So these two types of oscillations are possible. Both are represented by trigonometric functions, sine wave and cos wave. That's the only difference. What I taught is a sinusoidal wave. Listen carefully. Starts only from mean position. Okay?
Yes, sir.
And then given a push. See, it's like it's at 0, 0. I gave a push. So it went to this extreme at t/4. Then again t/4 it came back to mean position. Next t/4 went there, 3t/4. Then 4t/4 came back to mean position. This is my representation I gave in your class, number 1. What is given in the textbook? Because I thought that you might have read my notes and then read textbook. Totally different analogies are there. No, they are not totally different, one and the same. Now, in the textbook notation, it starts only from A, or it starts only from, mean they're taking the pendulum to an extreme position and they say, this is t is equal to 0. Let us start now calculating. Now they left it. Then what happens? It will go. This is 0. This is actually 0, 0. This is the mean position. Mean position doesn't change. Mean position is that only. But they started it from here. Understood? So at t/4 it will be here. Another t/4, that's t/2 it will be here. 3t/4 it will come back to mean position. And 4t/4 it will come back to the point where it started from. Understood? Is it clear?
Yes.
So this is represented by cos function, cosine function. What is the difference between starting only from mean position or starting only from extreme position? That is not just mathematical difference. That is an entity in oscillation that differs, that makes these two oscillations different. That is what I did not teach in the class number 1. That I am teaching. You know, that entity is called as, that entity is called as phase. Phase. What is this called as? Phase. Phase. Or phase factor. In chemistry, solid state chemistry, second year intermediate, you have this word, phase factor. Now in physics, we call it as phase. GHS, phase. What is phase? You should understand what is phase. Phase means, have you seen those marathon runners, they all
sir.
run in a circle. Yes. Have you seen?
Yes.
One of them would be, they would run like this. They won't run like from the start. They would not run like this. They run like this. Can you see this animation? They won't run like this. See, actually, they should, on a mark, get set, go. They should start all from, they should all be beside each other, right? They won't be like this. Have you ever seen it? Have you seen all of them? One of them is far ahead. Other one is little behind. Why is this happening?
Yes, sir.
Other one is little behind. Why is it? Why this injustice is being done with them? It's not injustice. Okay.
Like
All of them will run. All of them have a phase difference, but they all will run the same 2 pi r circle only.
Yes,
For
sir.
him, this is the starting point. For him, this is the starting point. For this person, this is the starting point. So for him to finish the race, he has to come back to where? Tell me. He has to come back here first.
Yes,
Then
sir.
he is said to be the winner. Now, for him to win the race, he should not come back here and say, I won the race. No, he didn't win the race. He's still lagging back. He has to come back here and say he won the race. Understood?
Yes,
For this ahead person to win the race, in the same time, he has to come back here and say, I won the race. Understood this thing?
Yes.
Now, that is what is called phase difference. Understood? They start off at different points. That's called as phase. In mathematics, of course, we don't know mathematics, but in a language of maths, we call that as orientation. You heard this. In maths, 10th standard, we had a chapter called trigonometry, remember? Heights and distances, remember heights and distances? How much you have to raise your head up to see Charminar, that is called orientation. Your head has to make some angle with the ground, no? That is called orientation. Above you have to see. Similarly, to see Durgam Cheru, you have to, what do you have to do? Can you see like this? No. You have to tilt your head downwards. You have to have an angle of depression. And you have to have an angle of elevation. That is the orientation. Orientation is basically angle. Angle, that's all. Okay. Understood that orientation? That orientation is only phase now. Understood? Now imagine these 3 runners. One is having orientation, this direction, this direction, this direction. All are having some phase differences here. Can you see that?
Yes.
All are having some phase difference. They're maintaining a phase difference. They're all maintaining a constant phase difference. Did you understand that? Now, if you understand this, you understood everything. Now, this sine wave and cos wave. Just a second. So, I'll switch off the. Yeah, now you can see. From morning I'm shouting. Yeah. So orientation is the angle, initial angle. It's called as initial angle, or in English there is another word for that. Epoch. It's called as epoch. Initial angle, also called as epoch. E-P-O-C-H. Epoch. Epoch means, see now again see these 3 runners. The 3 runners could be in the same direction. They're all oriented in the towards the. They are all maintaining a phase difference, but they are all orienting means their all heads are towards the audience only, right? Imagine there is one of them who doesn't like to run in this anti-clockwise direction, but clockwise direction, for example. There is one of them who wants to run in the clockwise direction. He is putting his head in this way. One of my finger is this way. Do you see? He wants to run in the reverse direction. So now you get it. That is epoch. Epoch is the orientation, in which direction they are actually doing the rotation. Is that clear? Now comes your S.H.M also, what we call oscillation. We have still not arrived at S.H.M. We still are undergoing only oscillation only. S.H.M will now be derived in this class. We are still in oscillation. In oscillation, these two types of oscillations I told you. One which starts only from mean position, one that doesn't start from mean position, but starts from the extreme position. Okay, that which is in the textbook and that which I told you, both you have to see. That which I told you is there in your NEET books, okay? NEET and JE and all the books. So you please buy MTG NEET Explorer book today. Okay, order it online in Amazon. Okay, that is very, very useful. Now the one which I told you is the object is object. So the body. Body is starting. Where is the object starting? In his case, it starts. His case it starts here. This is textbook notation. Okay. This is your NEET and all that. Now here it starts only from mean position. Here it starts from extreme position. Now how are these two represented as? So this type of a motion is represented by x equal to a sine omega t. That's how it's represented. This type of a motion is represented by x equal to a cos, not sine, cos omega t. This is how it's represented as. Why this sine and cos? Because both are, however, sine and cos diagrammatically represented, then you will understand this. Diagrammatically, this is, if I draw sine theta and cos theta, you would see this is how it is. Sine theta starts only from origin and goes like this. But cos theta doesn't start from origin, it starts only from extreme position. Because cos 0 is 1. I hope you know that.
Yes,
cos 0 is 1. But sine 0 is 0.
0.
That's the difference. So cos theta starts only from extreme position. See, this is my extreme position. So that extreme position, if I mark it here, starts like this. Do you understand? So if you mark that, no? See here? That's how it is. And you can see, when this becomes 0, when the sine theta becomes 0, you mark it down, you will get a maxima. When sine theta actually becomes 0 at sine 180, sine 180 is 0, cos is not becoming 0, cos is attaining maximum value. You see that?
Yes, sir.
Yeah. So that is how sine and cos are basically different in this way. Yes, you can see. And when this, see, this sine became maximum, cos has attained 0 value. So now you can see this is the difference between sine theta and cos theta. That is how the sine theta and cos theta are. That's how this particle oscillation is also. When in the first case, if imagine this, both are oscillating, okay? Imagine on this x-axis, both particles. One is from the mean position, other is starting only from the extreme position, okay? Imagine this goes to extreme, this comes to mean position. Is it or not? Yeah?
Yes, sir.
After that, this goes to this extreme, this comes to this mean position. So always these two particles have this maintenance of 90 degrees between them. They will always maintain a amplitude distance between them. Yes or no? That amplitude distance always it will maintain. When this will come back here, this would have gone here. Is it or not? So they will always maintain a distance of a. Yes or no? Yeah.
Yes.
That amplitude distance which it is maintaining in terms of phase, we call it as phi. Call it as phi. Phi is called as
Phi.
Phase difference, which is also called as epoch. Can you tell me what is the phase difference between sine and cos? That is epoch phi. Phase difference is given by 90 pi by 2. Phase difference it will have. Yes, no. Sine 90 plus. I hope you know that much math. Sine 90 plus theta is cos theta. Yes or no?
Theta.
All silver teacups. You remember that?
Yes, sir.
All
All silver teeth.
silver teacups. First quadrant, second quadrant, third quadrant. Remember that's what I thought. So all silver, T
Silver.
means tan, cups means cos.
Yeah.
Yes. That is how we got it. So sine any 90 plus theta or minus theta. Both are giving you cos only. Sine
Yes, sir.
90 plus theta is cos theta. And sine 90 minus theta also same answer, cos theta. And
Cos
both
theta.
will give you plus because first quadrant, second quadrant, sign are positive. In first and
Yes,
second
sir.
quadrant, sign is anyway positive. That's the answer.
Then in
So
first
now
and
did you
third
understand?
quadrant.
So can we represent this x1? Can I say this is x1 and this is x2? So this means that x1 is a function of time. Is given as a sine omega t. How this omega t came, I will explain. Okay, I'll explain. Omega. That's the big derivation. Now we have to do. How this omega
Yes.
t came, I will explain that. Okay, it's actually theta, no? How it became omega t, I'll explain that. Can be written as a cosine. Cos means cosine 90 plus omega t. Yes, of course. Yes. Yeah. So
Yes, sir.
there is a relation between x1 and x2. Understood that? Is that
Yes, sir.
clear? Yeah. So can we also say that x1 is nothing but x2 plus extra amplitude? X2 plus extra amplitude distance. No, it is differing always. Always x2 and x1 differ by amplitude distance.
Yes, sir.
In distance terms. Understood? In phase terms, this is how the equation is. Understood? So therefore, they differ by a phase. So the phase difference is pi. Epoch. Pi by 2. Understood? Is it clear?
Yes.
Right. So that much we understood. So in our general understanding as a student, what is phase? I will tell you. See, you have three subjects to study: mathematics, physics, chemistry, or botany, biology, physics, chemistry. Imagine you
Yes.
and your friend, both of you have to study these three subjects. No, you are always studying 1 hour extra physics, 1 hour extra chemistry, 1 hour extra mathematics. Eventually, because of this 1 hour extra you are studying compared to your friend, you are eventually getting an output of 5 marks extra. Understood? So the phase difference is that 1 hour extra that you are studying. What you will get output is that 5 marks. That is the amplitude. Understood? Amplitude is the displacement difference, final output difference. But input difference is there no between you and your friend, 1 hour extra you're studying. That is phase difference. Understood? Phase difference is the difference in the input, not output. Output difference is the amplitude or displacement difference. That is not what we're
Yes,
talking about. Understood? Is it clear?
yes,
Now,
sir. It's
having
clear.
known that, now we know all the characteristics and parameters of oscillation. What are all the final characteristics and parameters of oscillation? Something called as amplitude, I told you. What is
Yes, sir.
amplitude, I told you? Maximum
The difference
displacement.
between the-
Max displacement of
Yes, sir.
oscillating particle. We don't generally use the body term. We in physics we try to always use particle or very small body, very small bob like that. Amplitude we know. Yes. Frequency we know. What is frequency? Frequency is the number of oscillations done by the oscillating body in 1 second. Frequency is number of
oscillations done by the body in 1 second.
oscillations completed. These are all 2 marks answers. Completed by an oscillating body. oscillator. Sometimes in future, I will not use this big term to you, save some time. Oscillator, I will say. Oscillator means oscillating body. Understood?
Yes.
In 1 second, we learned this. Exactly reverse of that. The reciprocal of that is time period. Time period is defined as 1 by frequency or 1 by nu. I told you this, how to pronounce it. Nu. Or 1 by frequency, or it is the time taken to complete one oscillation or one
Yes.
complete oscillation. Complete.
Yes.
Now we know all these parameters. Having known all these parameters, now we can actually understand S.H.M, simple harmonic motion. Till now we have only understood two things. What is it? Oscillation means we know. Periodic oscillation we know, and we did numericals on periodic oscillation that day. Periodicity, I told you know what is periodicity. The time period repeats and take the LCM of all those. And in that, I have the day class finished. I told you know only sine and cos trigonometric functions are periodic. No other function is periodic. Exponential is not periodic. Exponential e power minus t is there. It is not periodic. Why? There is no such a e power minus t. If you plot it, you just understand this. E power minus t. If you plot it now, how it will be? It will go down like this. This is how it will be. It's not going to repeat itself. Not periodic. Okay. Log function, not periodic. Log x, not. So no need to even do it. You just simply know that. Okay. For BPC, you need not do all these things. You have to remember, that's all. Sine and cos are periodic. That's it. Rest all, any mathematical function they make you, forget about it. It's not periodic, you can say. Only sine and cos are periodic. And how to find the period, that day I taught you. Need not tell again. Having known that, now we are entering into S.H.M, simple harmonic motion. So when is this periodic oscillatory motion classified under a special category of S.H.M? When it obeys certain rules. To understand the certain rules, we have to take a S.H.M oscillator. So in your textbook, the derivation is not done properly. He just simply wrote the equation without deriving it, how it came. No, I am deriving it for you. Okay. Textbook, no, he has not derived it properly. This is a just look. Fine. So this is a circle. Okay. Your clock. I'm talking about a clock. Normal clock, wall clock. Wall clock. What does a wall clock have? It has a minutes hand. And of course, hours hand and seconds hand also.
Yes, sir.
We are talking about minutes hand. Or any, we can take any one of them. Take another color. Let us take this is hours hand. Smaller one. Now the hours hand and minutes hand both do the same thing. They both rotate like this. And when they rotate, this for example, they rotate like this. Is it or not? It rotates like this. When it does this rotation, now drop a perpendicular. What is perpendicular? You know what is a perpendicular? From the head of the hand, if you drop one straight line which touches the base, this is the base. What is a base? X-axis is your base. And this is your height. Height means y-axis. Y-axis is called as height. Yeah. Now, the same, this hand also will rotate, no? Even the seconds, minutes hand will rotate, seconds hand will rotate, both hands will rotate like this. So when they both keep on rotating, you can draw one more foot of perpendicular from this hand also. From this hand, you can draw. It's like shadow, basically. A shadow. I'm just drawing a shadow. Shadow of that will fall on x-axis also, right? Shadow of this will fall on the x-axis like this. Yeah. So to make it look like a shadow, what I'm doing is I'm going to make it dot 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 for you. Understood? This dot 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 means it's a shadow. Understood
Yes,
that?
sir.
So now this shadow will be here. Now can you tell me when this hand, any of the hand rotates, what happens to the shadow? Shadow, what happens to shadow? Where will the shadow move? Shadow will move on the
It
x-axis,
will
is it
be.
or not? Shadow will move
Yes, sir.
like this. Yeah or not? Shadow,
Yes,
first
sir.
where the shadow will be? At 0, 0 time. When the minute's
Yes,
hand was here, when the minute's hand, imagine the minute's hand was starting only from 0 degrees. 0 degrees means
yes,
at 3 o'clock. This is 3 o'clock. No? Yeah? Like this, circular it has to rotate, no, clockwise. I am taking
yes,
any rotation you can take, clock or anti-clock. Okay, circularly it has rotated like this. Yes. So when it was at 3 p.m., where is the shadow? Shadow is coinciding with itself, is it or not? Shadow is at the
yes,
extreme
sir.
position. Now when it comes here, goes on like this. You see? Now where does the shadow go? Can you tell me? Where does shadow go? Shadow will, just a second, can you give me 1
It
second?
will.
Not an important call. Just a second, student. So just pause and. Oh, sorry for the interruption. Yeah. Yes.
Yes, sir.
Yes. Am I visible? Yes. Ah, we are back. I just got an emergency call. Actually. Not Amazon people. Yeah. So as this rotates, what happens? What happens to the foot of perpendicular? Do you understand what is foot of perpendicular? See, this is how it's rotating. No, when this rotates,
Yes.
यहाँ का जो foot of perpendicular होगा, वैसे it will move like this on the x-axis. No, it will move like this. See, when
Yes.
this was at 3 p.m., foot of perpendicular will be coinciding there. When it goes to 3 p.m. से नीचे जा रहा है ना, 4 p.m. Then what happens? It will go back. 5 p.m. It will go even back. 6 p.m. when it will go, it will be here at the mean position. When at 7
Yes, sir.
p.m. it will go back behind. 8 p.m.
Sir,
9
it is
p.m.
like
Like that, it will
this.
extremely go to minus A. Then after that, when it goes up, no, it will go back. Yes or no? So the foot of
Yes.
perpendicular is oscillating along the x-axis. Yes, did you understand that? That is
Sir,
what they have given in the example. The body oscillating along x-axis is given as sinusoidal wave. They said, no, how it came. Now we are deriving it. In textbook also, this derivation is not done, directly written. How I am deriving it for you. Okay, listen carefully. So let us take initially only, see, initially you purchased a clock, okay, and the clock was a defective clock. Defective clock means it should start with 12 o'clock, no, and then it should go to 1 o'clock, 2 o'clock, 3 o'clock. Yes, correct. Initially, imagine you purchase the clock at 12 p.m. and it should start with from 12 p.m. But at 12 p.m. only,
Yes.
it is starting only at 1 p.m. So initially, it will show extra time. Is it or not? It will show extra angle.
Yes,
Do you understand? Extra, how much degrees is it? Can you tell me? 360 degrees divided by 12. Is it or not? 360 divided by 12. That
Yes,
angle there'll be an angle, no, theta. Let us take that as theta. So the theta angle extra always it will show, no. So your clock will show more time because it start at 12 o'clock. It is showing 1 p.m. At 2 o'clock it will show 3 p.m. Is it or not? Always it will show more time. So to know the exact time, what you should do? Of course, common sense will tell, why should I see like this? I would turn it back and put it there at 12 to 12. No. Think you have no operating screw, nothing or back there. You cannot do any adjustments. Then what you should do? You know that it is showing 1 hour extra. So you will always subtract. Yes or no? Because it started from 1 p.m. when it was 12 p.m. So you definitely know that it is showing 1 hour extra always.
Yes,
So
sir.
you will subtract one hour from the always reading. Yes or no?
Yes,
Understood this
yes, sir.
point? Imagine another situation. It should start at 12 p.m. but it started from 11. It was little behind. Now at 12 o'clock it is showing 11. So when it comes to 12, at 12 o'clock it is showing 11. So you have to always add 1 hour. Is it or not? At 12 it is showing 11. When it will come to 12, it was actually 1. It is showing 12. At 2 it is showing 1. At 3 it is showing 2. So you have to add 1 hour. Because it was behind, it started from behind, you have to add 1 hour. Yes or no?
Yes, sir.
Did you understand?
Yes, sir.
This logic you understood? So
Yes, sir.
now if you understood that, you understood everything. This is only phase. So initial angle, initial orientation angle is called phase, epoch. We call it as
Yes, sir.
EPOCH, epoch or phase. Initial phase is called epoch. Do you understand? This we cannot eliminate it. We have to, that plus or minus phi will be there in the angle. Always our angle will have extra phi or minus phi. Either it would have started only from negative or it was started from positive. Did you understand that? No. Now
Yes,
how to form the equation for this? So this x-axis, this is x-axis. This from here to here is your total amplitude. Let us imagine this is your amplitude. Is it or not? So when the body was here, from here to here, only at a particular foot of perpendicular, what is this x? No, this is only x. X distance. X is less than a. Yes or no? X is less than amplitude. So how do you get a relation between x and a? No, again, get back to the same thing. So see this. This is the clock hand. Clock hand. Started.
Yes,
If it coincides with your 3 p.m., the foot of the perpendicular is 0. There is no foot of perpendicular. Is it or not? Is it or not?
yes, sir.
Y-axis 0. X-axis total. X is equal to 8 became. X is equal to 8 became. Now that means,
Yes,
what is this? Total is A, no? Yes or no? So X is equal to A. If time t equal to 0. Did you understand this? Yeah? Now,
Yes, sir.
then it slowly goes down, rotates. Now let us take another coordinate here. X equal to plus A. Is it or not? This is your plus A. When t equal to 0. Now, this total time of rotation is capital T. Now, from here to here it has come. Then it is how much time? Tell me, child. If then that small t equal to capital T by 4, no? Yes. Then what
Yes,
is
sir.
x equal to 0? Why? How? This is x equal to A. Now,
Yes,
total t by 4, this t by 4 time it has taken. 1/4 day, 1/4, not 1/4 day, no? We call it as 1/8 day. But for our hypothetical situation, one rotation, let us take it as one complete rotation. So one complete rotation means 3 hours it has gone down. Means t by 4. T by 4, time by 4. Total is 12 hours. 12 hours is your capital T. In that it has gone from 3 o'clock to 6 o'clock. That means t by 4. In t by 4, what happened to x now? Originally x was amplitude. Now where is x? No x. Because it's lying on the y-axis. There is x is not there. X0. Did you understand that?
Yes, sir.
Huh? Clear?
Yes,
Understood this? Similarly, when it rotates and it comes here. Okay. I will draw all cases for you. Now this is the case. Okay. It's rotating like this. Did you understand this? This is minus a, no? Then this is again 0. Yes or no? Yeah. Do you get it?
Yes, sir.
Yeah. So when do you get it? This is x equal to 0. X0 but t. Now tell me. This is t equal to 0. Okay. Okay. Let us take from here. This is 0. At t equal to 0, x equal to a. T equal to t by 4. Small t equal to capital T by 4. X equal to 0. Then small t equal to how much? This is t by 4. Then this is t by 2, no? Half. Then x equal to how much? Minus a. Then again x equal to 0 for 3t by 4. Understood? Then again cap total t. Total t pe again a t become. Understood this? This coordinates understood? Huh?
Yes, sir.
Now x equal to what now? In this case, when it is here. So it is here a. When it's here 0. When it's here minus a. If small t equal to how much? T by 2. Understood that? Similarly, where it will be here, when it's here, again x will become 0. If small t equal to 3t by 4. Yes. Again, finally, x equal to again plus a. When? If small t becomes equal to 4t by 4. Yes or no? 4t by 4 means capital T. Understood? Started from 0, came back to itself. Where it was, it ended up there. Understood these points? If you plot these points on a graph sheet, they will look like a cos function. Let us plot these points on a graph sheet. Then what happens, do you know? You will get a cos function. You will get a cosine wave. Cosine wave. Plot these functions or plot this point. At x equal to, see, at t, on x-axis, what should I plot? What should I take the coordinate on x-axis? In my plotting, in graph, there is an x-axis, no? In graph, x-axis should be time axis. Time axis. In the graph sheet, the y-axis represents your displacement axis.
Yes, sir.
Understood that? Displacement means x coordinate. Now you don't get confused. What is this sir saying? He's saying x and writing on y-axis. Don't think like that. X here represents displacement along x-axis, which I am plotting on the y-axis. On x-axis, I am plotting time. Understood that? Okay. At t is equal to 0, where is your x coordinate? Amplitude. Set amplitude. A. Then at t is equal to t by 4. So I will divide this time axis into four parts. Okay. For our simplification, for our understanding. Okay. I'll call this as t by 4. The next coordinate will be how much? T by 2. Then how much? 3t by 4. Then it will be total capital T. Did you understand that? So first coordinate, I'll mark this with which color you like? Red, no, black color. So first point will be this. Yes or no? Second, x equal to 0 when t is equal to t by 4. Means my second point will be here. Yes? Understood that? Then where will it be? Minus a. So minus a means I need another coordinate, another axis downwards. Here, this is plus a. And this is minus
A.
Now tell me. Now at t by 2, where is it? Minus a.
Minus A.
Then, understood this? At t by 3t by 4, where is it? 0.
0.
Again, where it was? Then where, at this point, at t is x equal to t is equal to capital T, x is at a. Understood?
A.
So if I plot these points, how would I plot them? Okay. Okay. So this is how the plot comes. And this is a typical cosine wave. Cosine wave or cos function in 10th standard trigonometry. We have studied this cosine wave. Remember?
Yes,
Cos wave. We call it as cos, but we have to pronounce it as cosine. We generally pronounce it as cos. Understood this? Clear? Is that understood? So that is how they got this. Understood? So it has gone to one again extremum. See, this is the extreme. extreme is this amplitude. You can see it's going to that extreme. You can see that?
Yes, sir.
Now if I would have plotted the other way around means if I would have taken the point, starting point, not at 3 p.m. If I would have taken the starting point at 12 p.m. Okay. Now see, now see. Starting point only at 12 p.m. Then where is your t equals 0 now? At 0, where is it? What is x 0 now? At time 0, x also 0 because it has no x-axis here on the x-axis, no shadow, nothing. Now at
Yes, sir.
now here at t by 4, x-axis is a. Understood now? So that
Yes,
if
sir.
would have plotted, no, what I would have got, you know, if I have plotted that, I would get a sine wave. I will get. I will not get a cos wave. I'll get like this. Is it or not? I'll get like this. Yes. Why? See, at t equals 0, I'll get at 0. Then, just a second. Okay. So at t equals 0, x is 0 because 12 p.m. Then at 3 p.m. means t is equal to 3 by t by 4. It's at maximum, extreme. Is it or not? Yes. Then again,
Yes, sir.
you see, when it goes down, t by 2, it is at 0. No x-axis, no x-coordinate. Is it or not?
Yes,
T
sir.
by 2. Then again, after this part, x is equal to minus a, it will become. Why? At 3t by 4. Yes, this is 3t by 4.
Yes.
Yes, so this is 3t. It's minus a. Then finally it attains at t is equal to t, small t equal capital T. What happens? It will get back to 0. Yes, understood that? So this is called a sine wave, sine theta, or also called as sine omega t. Why I am writing omega t? Now I will explain. Listen carefully. We have definition in 9th standard about theta, angle theta can be represented as, see, when something is rotating, we define an entity called as angular velocity. So angular velocity or angular speed into time is called as angle. How? Because it's defined only like that. Omega is defined as theta by t. So then theta becomes omega t. That is how this omega t I'm saying now always. That is how it came. Understood that?
Yes, sir.
So that is why the sine theta, cos theta, we don't write. We write sine omega t, cos omega t. Now what about this phi? Where is this phi? In these situations, both situations, they were starting from either x-axis or y-axis. But I told you the faulty clock, it would start either backwards or front. It will either start only from 1 p.m. or start only from 11 a.m. Then what to do?
Yes.
Then there is a plus or minus phi that you should add. Therefore, x coordinate, x becomes sine or cos of omega t plus or minus phi. This is how S.H.M is represented. So either you use a sine wave or a cosine wave. Okay, sine or cos, you understood? Sine or cos
Yes.
of that thing. Okay, so I would have to write it as x equal to sine omega t plus or minus. It could be plus or minus. See, if it was starting from 11, then I have to add up 1 hour. If it's starting from 1 p.m., I have to subtract 1 hour. That's why plus or minus.
Yes.
Understood that? So I would like to write it in a this sentence I'm erasing just because I'm elaborating it, writing the complete sentence, complete phase. Either this or this cosine.
Yes, sir.
When is this and when is this? We have to use in our textbook, of course, they have used only cos wave. We may use sine or cos depending on where it starts from. I told you that also. If it starts only from amplitude, from extreme position, then you have to use cos wave. If you start from mean
Yeah.
position, you have to use a sine wave. For your understanding, I'm writing it. Starts from where? Mean position. Okay. This is starts oscillating, please. Here also. Starts what? Starts oscillating. From mean position. Starts oscillating from extreme position. Extreme position means amplitude. It starts only from amplitude. Amplitude is equal to x. Yeah. At t equal to 0, it starts only from extreme position. That I told you, simple pendulum example also I gave. Yes. It starts only like this. Then this is cos wave. If it doesn't start like this, it starts from mean position. I gave a push. I just gave a push. Start from here. So then it is sine wave. Understood that? You haven't understood that. Let us go down. Did you understand? So now we know the position. We know the equation of position. Yes. Now we need to find out the velocity.
Yes, sir.
Velocity V. V, normal V with a script is called velocity. First of all, velocity is also a function of time. Here only you will face some difficulty being a BPC student. You have to understand that little bit of mathematics you need to learn. You have to do. You have to learn that much of basic maths or differentiation is inevitable. You cannot avoid it. So I will teach you this. So V of t is defined as what? What is velocity defined as from 8th standard? Velocity is defined as displacement by time. But here we don't define like that. We define it as differentiation d by dt of x of t. This is x of t.
Yes, sir.
X, function of time. Displacement is in itself a function of time. Okay.
Yes, sir.
So V of t is a differentiation. So only one differentiation you need to learn and remember. What is that thing? Only one differentiation. D by dt of sine omega t is given as omega will come out, children, and sine becomes cos.
Yes, sir.
Okay. And similarly, d by dt of cos omega t will be, omega will come out with a minus, it will come out minus omega, and cos becomes sine. That's all.
Yes, sir.
That's all you have to remember. How it came, all that in bridge course again I will teach you, but now you just remember this much. Okay. This much you
Yes.
understood now. This. So using that we are going to derive it. V of t. D by dt of what is x of t? A cos I am taking. A cos omega t plus or minus phi. This is our function according to your textbook. So if you differentiate, A will not change anyway. This omega will come out and there will be a minus because cos differentiation is sine. Yes.
Yes, sir.
Sine omega t plus or minus sine. Understood? So this is your velocity function. Understood that?
Yes, sir.
So you understood what is a velocity function clear. Yes. So having understood that, we need to understand also the acceleration function. It's called acceleration.
Yes, sir.
Acceleration is defined as what? Rate of, here also velocity is defined as what? Rate of change of displacement. Here, rate of change of
displacement.
velocity. Velocity itself changes, then it is called
Yes.
as acceleration. If
Acceleration.
displacement changes with time, it's called as velocity. And if velocity changes with time, it's called as acceleration.
Acceleration.
So that's again you have to differentiate. What else you have to do? So it is defined as d by dt of v of t. V of t is d by dt of p of t. So again, let us do that. D by dt of what is v of t? This is v of t. Equation number 2. So equation number 2 means what? What do you write here? Minus a.
Minus
There is
a
an omega.
omega sine.
Sine of omega t plus or minus.
Plus or minus 5.
So there here sine differentiation is there won't be any. When you differentiate sine theta, it becomes cos theta and there won't come out any negative. So there is one
Yes,
negative, it will remain as it is. So minus a will remain.
Okay.
Only one omega will come out, but there is already one omega. So what happens? Omega square will come out. Understood that? If you don't
Yes,
understand,
sir.
write it. Omega is already there. Into an extra omega comes. And sine becomes cos.
Sine becomes cos.
Understood that?
Yes, sir.
Why it became and all that we need not learn. Just to remember.
So, like, isn't it plus or minus 5?
Plus or minus. Yes, of course. Plus or minus.
Yes, sir.
Plus or minus 5. Okay. So minus a omega square cos omega t plus or minus 5. Okay. So this,
Yes,
if
sir.
you look at this, what do you observe? If you see this acceleration function, what do you observe? Let me corroborate it. If I take that omega square outside and I will reorient it, see now you will see what a wonderful thing it is. Omega t plus or minus. What do you see? What is this function? That is the first equation. Equation 1.
Yes, sir.
Yes or no? This is the equation 1, which we have taken as the displacement function. Yes. So it is nothing but minus omega square x of t. Is it or not?
Yes, sir.
So this is harmonic nature. Now we have understood what is harmonic means. Amplitude should be, now this is the part which tells you about S.H.M. Okay. This
Yes,
is
sir.
harmonic. This is the part which tells about harmonicity. Harmonic means the function is said to be harmonic if the acceleration is directly proportional to displacement and opposite in nature. Yes, so it is following that rule. Understood that? Yes, did you
Yes, sir.
understand? So A is proportional to X and A is proportional to minus X. So this is simple harmonic motion. Yes, understood that?
So, this is the derivation, sir.
This complete derivation is your 8-mark answer.
Okay.
So from here, what all I taught you, all this you have to write 8-mark answer. Whole thing is there in your textbook. That's not still complete. Only one more graph is there. This graph also you have to draw. Then the 8-mark answer completes. Graph and draw. There in your textbook. So we are going to now plot the graphs. Graphs means x, velocity and acceleration as function of omega t. So x of t, I will call this as x of t because it's a function of time. It's a function of time. It's a function of time. What is x of t? We have taken a cos omega t plus or minus 5. Similarly, what is this? Minus a omega sine omega t plus or minus 5. Then this was minus a omega square cos omega t plus or minus 5. Yes. Now, if you plot these graphs, first one is a cos function. So it is very simple to plot. How will it look like? Here, like this. This is amplitude. This is 0. Let us take this as t by 4. Okay. Like this here
Yes.
also. I'll put that t. Yes, understood. So here is my t by 2. Then this will be my 3t by 4 and this will be my t. Similarly here, exactly below this your plot. Then only it makes sense. Otherwise, arbitrarily you cannot plot it. Exactly
Yes, sir.
below that plot. Understood that?
Yes, sir.
Exactly below this. Now let us plot the graph. At 0, what is happening? What is it starting from? Cos function starts only with amplitude, no? It already
Yes, sir.
starts from amplitude and then goes to 0. We already plotted how cos looks like. Rough graph is like this, no? Like
Yes,
this,
sir.
is it or not? So let us draw the graph. So here one point. After that, next point will be like this. Yes or no? After that,
Yes,
at t by 2, it will be negative. Is it or not? Here, minus
Yes,
a
sir.
will come. This is plus a, minus.
Mine.
At t by 2, you must get a negative graph. Negative. So, what do you get this? How do you get this? Yes or no? Understood that?
Yes, sir.
So we have to draw very, very precisely. You can't just simply draw arbitrary graph. So I'm drawing as precise as possible. Because at t by 2, it should go negative. Yeah. That's good enough. Now, at t 3t by 4, it will become 0. And then at t, it again goes to extreme. Yes?
Yes, sir.
This is how it should be. Yeah, the same thing. Do you see this? This is also cos and this is also cos. Yeah or not? Yes or no? So both will look alike. Then what is the difference? Can you tell me? What is the difference? What could be the difference in this and this? This. This is the difference.
The omega square, sir.
Yeah, that omega square extra term came into existence. And one more difference is there. You have not observed that. One more difference is there. Tell me. There is a minus here and there is a plus here. This is plus and this is minus. So can you tell me what this graph would look like? When this is 0, when this is a plus a, acceleration will be minus a.
Yes, sir.
When that is plus a, you would have a minus a here. Yes or no? Clear? That also will be not minus a. It will be a bigger one. Minus a omega square will come. Yes or no? So it would start only from downwards. Yes?
Yeah.
It will start
Yes,
like this.
And it will move up.
And when this is negative, it will give you positive. At this here, you see, this you got negative. Here at t by 2, it will give a positive value. Yes or no? Here it will be a positive value. So at t by 2, it will be positive. And at this 0, 0 doesn't have positive, negative. So no problem with 0. Yes?
Yes, sir.
After that, you see here plus a came in this, that case at t. Here minus a will come. Yes? Minus a means minus a omega square will come.
Yes, sir.
And this is plus a omega square. Extreme point will be. Yes? Did you understand that? Clear? Now let us plot velocity graph. Velocity graph is having a negative starting and it is having sinusoidal. General sine wave, generally what is sine wave? This is how its sine wave will look like. But it is minus sine wave. Minus sine wave will be looking like this, ulta. That's all, no?
Yes, sir.
Understood? So it will start from 0 and it will start from 0 and at t by 2, it should get actually maximum this side upward, but at t by 2 it will get a maximum downward. Understood that?
Yes, sir.
So here this is 0. It starts at 0. At t by 2 it should get, see, we're not able to plot the graph here, no place here. What to do? So it will be like this. So at t by 2, maximum value will come. I will plot with some other color. Now you see, at t by 2, maximum will come. And at t, it will end up. It will end up like this, it will come. Yes or no?
Yes, sir.
No place. Okay, I'll plot that downward here somewhere. No place here. No, that's the problem. I'll try to rub it with it. This line I'll take it. Okay, now. Now I think we got some place. So here what should be the maximum? Minus a omega should be the maximum. Yes or no? So it should start with 0. Yes, at 0 it is 0. Sin theta, sin 0 is 0 only, no? And
Yes, sir.
sin 0 is 0. And then sin 90 is 1, but minus 1. This is only sin 90.
Yes, sir.
And sin 180 is 0. So it should start like this and go here. Yes or no? 0 to t will go like that. Yes or no?
It should be 0 at t by 2, right, sir?
So I am drawing with dot line. Is it okay for you?
Yes, sir.
There's no
That's fine.
place. No, now it should go like this. Yes or no? Understood that?
Yes, sir.
Is it clear? That is how
Yes,
it will
sir.
go. Understood that? Sin theta graph. That's all. Okay.
Yes, sir. But sir, like in the textbook, it's showing that like it'll be 0 at t by 2, sir.
Yeah, wait. T by 2 is not 90. Wait a second. T by 2 I have taken at okay, yeah, because T by 2, his T and my T are different. Okay. I'll plot the textbook provision. What he has done, his time period is 2 pi. I am taking in terms of time. No? See here, you see, at 0 it is 0. T by 4 means what? 2 pi by 4. That is only 90. T by 4 is only 90.
Yes, sir.
T by 4 is only 90. Here it should be. And T by 2 is pi, 180 degrees. So it should go
Yes,
like
sir.
then here it will become maximum again. Here it will achieve maximum. So like this. So this is your extremum.
Yes, sir.
What is that? Minus a omega. And this is your what? This is plus a omega. And this is your minus a omega. Understood? Yes.
Yes,
So
sir.
this is how it is. This is reverse sine wave. That's all. This is your cos wave. And this is your reverse cos wave. That's all.
Yes, sir.
Understood? Is that clear?
Yes.
So we plotted a complete, all the waves we plotted. Sine wave, my reverse sine wave, cos wave, reverse cos wave.
Cos wave.
Displacement, velocity, acceleration. All are done. Here time period means what? Time period means 2 pi. Capital T means 2 pi. Okay. 2
Yes,
pi
sir.
by omega. 2 pi by omega. How this came? Let me explain that. How this 2 pi by omega came? Omega by definition is what? Total angle by total time. So what will this be reverse? So T is equal to
2 pi omega.
Understood that?
Yes, sir.
Clear? Now we understood everything. Now this is only 8 marks answer completed here. Along with one small numerical they may give. IP, sometimes they may give, sometimes they may not give a numerical. Now the next 4 mark answer and what is there in your textbook. That is S.H.M in a spring.
Yes, sir.
S.H.M in a spring, or what is called as Spring balance. Sometimes we call that as spring balance.
Yes, sir.
After that, last is simple pendulum. S.H.M. spring. This is a normal spring, an unextended spring. This is unextended, means normal spring without any extension. Okay, the pen, you see, normal, unextended. Unextended spring it is. So in spring, what happens? When you press the spring, it will try to extend. Yes or no? When you press it, means you are applying a force. You are actually compressing a spring. But is it happy? Will it stay like that? No, it will try to elongate. And will it elongate to its original mean position? No, it will elongate more actually. So after that, it will execute oscillations. It will oscillate. Is it or not? Yeah. So that's what a spring does. So that day I taught this concept of a spring. So spring has this property. If you compress the spring, you are compressing. So what happens? You are compressing. Compression. So from where it has got compressed? It was actually here. It has got compressed this much x. But it would try to go this side, this direction, opposite to your compression force. Compression is a force and displacement is in this direction. You're compressing in this direction, but it'll try to restore. Yeah, that's the correct word.
Yes.
Restore. Restore in the opposite direction.
Yes, sir.
So it will try to always restore in the opposite direction. So that clearly signifies that the force applied and the displacement or of restoration are proportional and opposite. So it is like F is proportional to minus X. So that proportionality constant has been given as K minus Kx. And this K is called as, this K is not that phase K. No. This K is called as force constant of the spring or elongation constant. Elongation constant. Sometimes this is only called as extension constant. Extension constant or compression constant also. Because either of it will happen, no? Compression constant. Elongation or compression, one of them will happen. Is it or not? So elongation constant or compression constant. Okay. Or force constant. In general, in our textbook of IPE, we call it simply force constant. Why do we call that force constant? I'll explain again. K is given as F by X. It is actually, see, on that spring pen, if you see, no, that is what spring pen, if you compress, you can't compress further on. If you press a lit, if you try to compress or extend, either of it you can do. You compress, how much maximum you can compress it? This is the spring. Can't compress it to 0.01 millimeter. You can compress it up till all the rotations of the helix of the spring touch each other, right? That's the maximum compression you can do. Yes. Extension also, you can't extend it and make it a line. Can't make it a straight wire. Is it not? You can extend it up to a certain level. After that, if you extend with by applying your muscular power, it no longer remains a spring. It will become finally it will become a wire. It won't become a spring. It will not stay as a spring only. It has to come back to the original spring. So maximum force applied by maximum extension produced or maximum compression produced. That is called as F max by L max. Understood? Or this is only called as dF by dx. So maximum force, maximum permissible force by maximum what? Extension.
Yes, sir.
Extension or compression. That is allowed. Because above that you can extend or compress, but it will no longer come back to the original spring. It will not come back to the original situation which the spring was. It will deform. It's no longer the original thing, right? So this is how it is defined. Did you understand? So that is F is equal to K by X, and the dimensional formula of this K, they will ask in MSET and the NEET bits. Dimensional formula of K is, the unit first of all is Newton per meter, and the dimensional formula of that is what? M power 1, L power 1, E power minus 2, that is force, divided by L power 1. What would you get? M power 1, L power 0, T power minus 2. It's very important in NEET bits. Force constant dimensions, they're asking many times. Understood this? Yeah, that's it. So now we understood, but we know Newton's law says that F is equal to ma. Newton's law, according to Newton's second law, the force is given by mass into acceleration. What is the mass? Mass of the spring into acceleration produced in the spring. So now we got it.
Yes.
So ma is only equal to minus kx. Just understood that much? Huh? But what is acceleration in S.H.M? In S.H.M, what is the meaning of acceleration? Go up, go up. See what is acceleration? What is acceleration? You see this? This is where we wrote. I wrote here. I wrote.
Yes, sir.
Acceleration is minus a. If you take out that omega square, what will it be?
A cos.
If you take a cos, what is that? X, no? X,
Yes,
isn't
sir.
it? It's simply omega square x. You see that? See here, I wrote that.
Yes,
This
sir.
is equation number B. The equation number B. Acceleration in S.H.M is minus omega square x. Yes or no? You written that in equation B. So now you write this here. M. Instead of A, you write minus omega square x
Yes, sir.
equal to minus kx. So can I cancel x on both sides? Of course. What would I get? Minus also can cancel. What would I get? Omega square is equal to
K
K by M. So what is omega?
root over K by M.
Understood this? Very, very, very important for you to understand.
Yes, sir.
This is not derived in your book, just written directly. How it came, nobody wrote that. Understood this?
Yes, sir.
From this, we get the time period of the spring. What is time period? 2 pi by omega. So it is 2 pi root m by k. Reverse, reciprocal of this. Understood that?
Yes, sir.
Is that clear? In
Yes, sir.
general, in NEET bit I am telling, this is not there in textbook. In general, time period is given by 2 pi. For other types of pendulums, I told you, not only simple pendulum, there are other types of pendulums which will come in your
Yes.
NEET book. Okay, they're called as compound pendulum, body pendulum, solid pendulum, physical pendulum. So for that, there is a direct formula. That is, instead of mass, you have to say inertial element.
Yes, sir.
Inertial element by force constant. Okay, inertial element by force constant. Okay, you will learn about this. Why this inertial element on there? I will tell you next class. Is you understood? Force constant or force element or applied force constant, force element. Sometimes we say that. Restoring element. This is called a restoring element. Correct word is restoring element. Inertial element by restoring element. Correct definition is this. Root over
Yes.
inertial element by restoring element. What is the restoring element? Here force constant, but not always. Sometimes restoring element may be something else. Alpha, it could be alpha, it could be theta, it could be anything. Inertial element here is mass. It could be moment of inertia I. You will learn that. Okay. Understood it. Yeah, our time is up.
Yeah.
Actually, I have next class. Yeah. So last time is almost finished.